Ready to test your multi-source graph skills? Pacific Atlantic Water Flow is a Pattern Mastery 100 standout, and a frequent challenge at Google and Amazon for Grid DFS/BFS mastery. More than 30% of candidates stumble on multi-source propagation or state tracking. Master this and you'll be ready for any two-way reachability problem in grids or graphs. Let's solve Pacific Atlantic water flow using the basic approach, a robust method for systematic, interview-ready solutions. Given an MXN grid of heights, return all coordinates where water can flow to both the Pacific and Atlantic Oceans. Water can flow from a cell to neighboring cells with equal or lower heights. The Pacific touches the left and top edges. The Atlantic touches the right and bottom edges. 2D grid of integers, heights list of coordinate pairs, row, col, where water can flow to both oceans. Think about rainwater flow on a terrain map. Where could water reach both rivers? Interviewers might ask, how would you find all meeting points in a network from multiple start sources? What's tricky? Water flows uphill in this reverse sense. We can visit a cell if it's equal/higher than the previous, simulating water flowing down from it. Need to find cells that can reach both oceans, not just one. Must avoid redundant searches, propagate from oceans inward, not from each cell out. For each ocean, mark all cells that can flow into it. Pacific, start from all top and left edge cells. Atlantic, start from all bottom and right edge cells. From each ocean border, use DFS, or BFS, to move to neighboring cells of equal or higher height, reverse water flow. Collect cells reachable by both DFS runs. The intersection is the answer. Let's clarify. 2 visited sets, one for Pacific, one for Atlantic. Each DFS only goes uphill, to equal or higher height. Final answer is the intersection of the 2 sets. Edge cases. Empty grid, return. Single row/column, all cells touch both oceans. Flat terrain, all cells can reach both. Initialize 2 visited sets for Pacific and Atlantic. For all Pacific border cells, top row, left col, DFS/BFS and mark all reachable. For all Atlantic border cells, bottom row, right col, DFS/BFS and mark all reachable. Result equals intersection of both visited sets. This problem is all about figuring out which cells can flow water to both oceans. Instead of pushing water downhill, we cleverly reverse the flow. We start DFS from the oceans and move uphill, marking any cell that can eventually reach that ocean. Then we simply find all cells reachable by both oceans. Approach, DFS from ocean borders. Time complexity, OMN. Defines movement directions, down, up, right, left, for DFS exploration. Main method, returns all coordinates that can reach both oceans. Stores number of rows, m, and columns, n. Grid to track which cells can reach the Pacific. Grid to track which cells can reach the Atlantic. Start DFS along the top row touching the Pacific. Start DFS along the left column touching the Pacific. Start DFS along the bottom row touching the Atlantic. Start DFS along the right column touching the Atlantic. Creates result list for cells reaching both oceans. Iterates through the entire grid, row by row. Iterates through columns of each row. Checks if a cell is reachable by both oceans. Adds such a cell's coordinates to the result. Returns the full list of valid coordinates. Helper DFS function to propagate reachability. Stops if this cell was already visited for that ocean. Marks the cell as reachable by that ocean. Loops over possible movement directions. Computes neighbor cell coordinates. Ensures the neighbor is inside bounds. Moves to the neighbor only if not visited and height is greater than or equal to current, reverse water flow. DFS onward into the valid uphill neighbor. Ends movement condition. Ends loop over directions. Ends DFS method. And that's how the Pacific Atlantic water flow algorithm works. Efficient, simple, and elegant. Now let's verify the solution using the provided test input. This grid represents land heights. Water can only flow from higher/equal height to lower height, but remember, we reverse the flow, starting DFS from each ocean and exploring only uphill paths. We want cells that can be reached by both Pacific and Atlantic DFS waves. The algorithm marks all cells that can reach the Pacific, then all cells that can reach the Atlantic. Any cell marked in both Boolean grids is added to the final answer. This output shows exactly the cells that satisfy the rule. They are reachable by water flowing toward both oceans. Since it matches the expected output perfectly, the logic has behaved exactly as intended. So our solution checks out, the result matches the expected behavior, and the algorithm handles this test case correctly. Let's walk through this solution. The main goal here is simple. Find all cells where water can flow to both the Pacific and Atlantic Oceans. If we don't correctly track where each ocean can reach, we'll miss or wrongly include cells. If we correctly expand from both oceans and take the intersection, everything works smoothly. Approach, BFS from ocean borders. Time complexity. OMN defines the 4 directions, down, up, right, left, used to move around the grid. Starts the main method that returns a list of coordinates reaching both oceans. Gets the number of rows m and columns n from the grid. Creates a grid to mark cells reachable from the Pacific. Creates a grid to mark cells reachable from the Atlantic. Creates a BFS queue for Pacific reachability. Creates a BFS queue for Atlantic reachability. Loops over all rows to handle left and right borders. Marks the left edge cell in this row as reachable by the Pacific. Adds that Pacific border cell to the Pacific BFS queue. Marks the right edge cell in this row as reachable by the Atlantic. Adds that Atlantic border cell to the Atlantic BFS queue. Loops over all columns to handle top and bottom borders. Marks the top edge cell in this column as reachable by the Pacific. Adds that top edge cell to the Pacific BFS queue. Marks the bottom edge cell in this column as reachable by the Atlantic. Adds that bottom edge cell to the Atlantic BFS queue. Runs BFS to expand all cells reachable from the Pacific side. Runs BFS to expand all cells reachable from the Atlantic side. Creates a list to store coordinates that can reach both oceans. Loops through every row in the grid. Loops through every column in the current row. Checks if this cell is reachable by both Pacific and Atlantic. Adds that cell's coordinates to the result list. Returns all cells that satisfy the both oceans condition. Starts the BFS helper that spreads reachability from one ocean. Gets the grid dimensions for this helper. Processes BFS until no more cells are in the queue. Takes the next cell from the queue. Extracts the row and column of the current cell. Checks all 4 neighboring directions from this cell. Computes the neighbor's row and column. Ensures the neighbor is inside the grid boundaries. Moves to the neighbor only if unvisited and its height is at least current cell's height, reverse water flow. Marks the neighbor as reachable from this ocean. Pushes the neighbor into the queue to continue BFS. Ends the condition for moving to this neighbor. Ends the loop over all directions. Ends the BFS helper method. And that's how the Pacific Atlantic water flow algorithm works. We're now going to verify that this solution behaves correctly on the given test case. This is a 1x1 grid with a single cell of height 1. That one cell touches both the Pacific, top/left edges, and Atlantic, bottom/right edges, so it's important because it should clearly qualify for both oceans. The algorithm first marks this cell as both Pacific and Atlantic reachable from the borders. Then BFS runs but has nowhere else to go. In the final double loop, It sees PAC00 and ATL00 are both true, so it adds 0, 0 to the result. This output makes sense because the only cell in the grid can reach both oceans by definition, and it correctly appears as the single coordinate in the result. So our solution checks out, the result matches the expected behavior, and the algorithm handles this test case correctly.